vector u plus vector v, and that is the resultant. Okay? So the word, it may not say this vector plus that vector, it just may say find the resultant of this vector. Got it? Alright, so what you learned yesterday is if I take component 4 here and component 5, that's going to be how I find my resultant for the new component. So 4 plus 5 is 9. Then I'm going to take component B here and component B here, and I'm going to get my new component, which is
13.
Did he mean 12? He meant 12. Okay? We're good?
That's all.
That is all.
Could you repeat that?
Yes. So we're going to do it again. I'm going to repeat it 3 times, actually. So looking here at number 2, I have this vector 2, 6, and this vector negative 3, 1. And I want to find their resultant. I want to add them together. So I'm going to do 2 plus negative 3 is?
It's negative 1.
And then I'm going to do 6 plus positive 1, which is?
6.
So my resultant is negative 1, 7. Yay?
Yeah.
Okay. On 3, I'm going to
Add your both your x's. You get 2.
and I get 2.
2.
And then 5 minus 7 is?
Negative 2.
How do we feel? I'm going to give y'all 2 minutes to do 4, 5, and 6. Good. Just ignore him, Brady. Just ignore him. Sleepy.
Me too.
What if it was a what?
What if the 0 was a 5? Would it just be 5 square root of 3?
Yeah. No, it would have been square root of 3 plus 5.
Like inside the square
Would
root
it
of
be?
Yes. Everything must be like terms in order for them to become 1. All right. So how do we feel?
confident.
Okay. This is vector addition computationally. Okay. Computation means that you're literally just adding or subtracting or multiplying and dividing it with your hands, calculator, with your feet, whatever you count by. Okay. All right. What you did yesterday was you worked on it geometrically. You were given your points and you connected those points, correct? And then you counted your boxes, right? Your unit boxes. You counted and found what those components were, and then once you found the components, you knew it and you were done. Okay, that's what happens geometrically. What we're going to do is there's 2 ways to solve it geometrically. Way number 1 to solve it geometrically is basically using it as a freehand sketch, or basically saying that when I start from the origin, instead of going back to the origin, I'm just going to feed off where I stop at on this vector. And that's called tail-to-tip method. Okay? Way number 2 is called the parallelogram method. And with the parallelogram method, it's saying that I'm going to start both vectors from the origin, and then I'm going to find their diagonal. If they create a parallelogram, I'm going to find their diagonal. Make sense? Yes, no, maybe so.
So, I thought the origin for the first vector would be, the second origin.
Oh, there's only one origin.
Yeah, from U. See where U is at? Can't you still use it from that the same spot?
If you're doing tail-to-tip method, yes, that's what I just said.
I was making sure. That's what I heard.
Okay.
But
Alright.
it'll tell you which one you need to use.
So on your quiz or your test, I'll tell you whether I want you to prove this by tail-or-tip method or prove it by parallelogram method. So that's why we need to know how to do both.
You show me your number.
We are. That's why they're blank.
Is this what we did the day that you were gone?
No. This is what you did yesterday while I was here.
Well, no. I know that. I was saying like finding the diagonal.
Finding-
Give us that worksheet. Oh, okay.
That was yesterday.
Never mind. I was talking about the paper that we did when we
When you're using the distance formula?
Yeah.
Yes.
Okay.
It was similar. All right. I have to think about what you're reading. So I figured out how to draw the grid and make it all fit. So if you go 3 squares in and draw your y-axis, and then go 3 squares up from the bottom and draw your x-axis, you should be able to fit it. telling you, this board and I are not friends. Okay, so there's my axis. So I'm going to start with the first vector it gave me. Remember, the first component tells you whether left or right you're going, and the second component tells you whether up and down you're going. So I have a -3, so that means I'm going to go to the left 3. 1, 2, 3. And then I have a +4, that means I'm going to go up 4. 1, 2, 3, 4. So my vector started here, but it's going to end there. And that is vector U. Now I'm going to do vector V. With the tail and tip method, what that means is I start where I stop this vector at. So I'm going to start here, and I'm going to go 8 units to the right. 1, 2, 3, 4, 5, 6, 7, 8. And then I'm going to go 1 unit down. So this is where my vector will stop at. And that creates vector V. So by using this tail to tip method, I can now easily find the resultant of them. So the resultant is,
It should give you your same
okay?
result.
So my resultant would be, I'm going to go 1, 2, 3, 4, 5. So 5 to the right, which is positive. And I'm going to go 1, 2, 3 up, which is positive. So my resultant is 5, 3. So this is how to prove your resultant geometrically. To check it computationally, what's -3 plus 8? And what's 4 minus 1? So did we do it correct? Did we prove geometrically that this is our resultant? Okay, that's using the tail to tip method. And this is what you did yesterday. Right? So you did this yesterday, but you plotted the points yourself, and then you found the components, and then you recognized the pattern. All right, so we're going to do the grid again. Again, it's the 3 up, 3 in. Works best. Okay, so with parallelogram, both vectors are going to start from the origin. Got it? Both vectors start from the origin.
So basically just platforms.
No, you're still counting.
Oh.
I'm going to go 2 to the right, and I'm going to go 4 up, correct? So I'm starting here, 2 to the right, 1, 2, go 4 up, 1, 2, 3, 4. So my vector started here, and it ended there. There's vector U. So I'm going to do vector V. Again, it's starting at the origin, and I'm going to go 7 to the right. 1, 2, 3, 4, 5, 6, 7. And I'm going to go down 1. So I'm going to end there. And there's vector V. If both of my vectors start at the origin, this is how they will look. And because I do not have a tail and a tip, I have to create a tail and tip for me. Okay? Parallel. When something is parallel, what does that mean about them? They have the same
Same
what?
pain, direction.
Not same what? Starts with an S.
Similarity.
Slope. Okay? Parallel lines have the same slope. Okay? If they have the same slope, that means they'll always just be parallel and they'll never intersect or touch. Okay? That's the only way that lines are parallel, is that they have the same slope. And slope, again, is your rise over your run. So looking here, what is the rise over the run here? Well, at this point, I would rise 1 and run 7, right? All right, so it's the same thing as here, saying, what would this be? So I would rise 1, and how much should I run? 7. So it's the same, this is my rise and my run. So looking over here, can I recreate it here? Okay, so in this case, we dropped and then we ran 7. 1, 2, 3, 4, 5, 6. Is that 7?
Yeah.
Did I go over now? Sometimes I'm not sure about my drawing abilities. Let's go and pretend that's parallel. Okay? So now I have a tip that I can go to. Because my tails share the same spot. But they have, initially I had separate tips. Now I have a common tip and a common tail.
How did you establish that V would go?
My slope, remember we just talked about it had to have the same slope? So if I know the slope here, then the slope here needs to match that. Slope, rise over run, or fall over crawl. I don't know if y'all ever heard it that way.
So you gotta do that end point to the original, back to the original.
So I build, and then I run. So I'm gonna fall, then I'm gonna run, and that's gonna create that slope.
This one, they all start from the origin.
Huh? This is when they all start from the origin. Okay? So, what is it? 1, 2, 3, 4, 5, 6, 7, 8, 9. And then how much did I rise? 3? And then I rise, is it 4? 3? 3, sorry. Sometimes these lines tell you, we don't get along. And again, this is proving it geometrically. So computationally, let's check. 2 plus 7. 4 minus 1. 3. Good to go. All right, so that's it for addition. How do we feel about addition? Good? All right, what we're going to go on to now is multiplication, aka scaling vectors. Think about the word scale factor. When you have a scale factor, what are you doing? You're scaling a factor, huh? You're not comparing it.
You're doubling.
Well, you're not always doubling, but a scale factor does what to something? It's like a dilation. It's changing the size of it, right? When I have a scale factor, I can either say that it's going to make it bigger or it's going to make it smaller. That is what a scale factor does. That is what scaling of a vector does. If my scale factor is greater than 1 or greater than 1, that means it's going to make my line longer. If my scale factor is less than 1 but greater than 0, it's going to make my line smaller. Okay? Does that make sense? So if I have a line and my scale factor is a half, what did I just do to that line? Cut it in half. And it's not a half between 0 and 1? Okay? That's what it's saying. It's literally just, we'll just do it. All right? The scale factor, the result of the scale factor is called a scalar. So if I ask you to find the scalar of z with a factor of 2, that's what I just said here. That means I want you to multiply the components by 2. Okay? Again, it's called your scalar. Sorry. All right, so we're going to find the scalar of z with a factor of 2. So if I have 2, oops, not supposed to use parentheses because we are talking about vectors. 6, negative 2. So my scalar is 12, negative 4. That's it. The scale factor affects both components. The scale factor affects both components.
So can I skip or we go to 15 real quick?
We're going to.
Yeah, I'm just saying.
Oh, we're going to do 9, 10, 11, and 15 and 16.
It's just so easy compared to what we just did.
It's easy.
Okay, so then here I am now finding the scalar of w with a factor of 2. So it's 2. W is already negative 4, 5, but now I want to double it. I want to double its magnitude. So it's going to become okay. This is 0.4. 0.4 is between 0 and 1. So what's going to happen to my w vector? It's almost going to, it's going to cut it a little more than half, right? Because a half is 0.5.
I got 2.6.
It's not 2.6.
3.6.
It's not 3.6.
This calculator, I can't use it.
2.4.
God dang.
All right, here we go. So 0.4. My current measurements of my vector are negative 4 and 5. Oh my gosh, really?
Oops, negative 1.6.
All right, what's 4 times negative 4? Well, what's 4 times negative 4? It would be negative 16, but I have a decimal, so it's
0.1.
negative 1.6.
Nice.
What's 4 times 5?
20.
20, but I have a decimal place, so it's
2.0.
What?
Don't know why y'all were struggling with this calculator.
I
You didn't need it.
can't.
You don't need it.
Well, some of us do.
What's 4 times 5, Joanne?
It's an emotional.
And I have 1 decimal,
emotional dependence.
so it's 2.0. Okay, you guys, you don't need it. I promise. All right, here we go. We're gonna do 15. Well, luckily for us, did we already find the scalar here? Before you add and there's a scalar involved, before you can find the resultant, you must find the scalar first. Okay? Before you can find the resultant, you must find the scalar first. Well, lucky for us, we already found this. So this would be
-2.8.
I guess we got
6, -2, plus, and -8/10. So what's my resultant?
I got -2 and E. Sock it to me, Kate.
Okay? On 16, have we not already found the scalar for 2z? And we got
I got
12.
8.
Goodness gracious. I think I need a new
8 and 1.
battery.
8 and 1.
So it's 12, -4, and my W is -4, 5. And so my resultant is 8, 1. It's a positive uno, right? All right, I'm going to leave the 4 for you to do. I'm going to give you about 5 minutes. That should be plenty of time. All right, what was 12?
9 and -3.
Okay, what was 13?
-24 and 8.
What was number 14?
12, -15.
All right, what was number 17?
24 and -9.
It's 19.
14, that's wrong.
I got 24 and -9.
Should be -19.
Oh, wait.
19.
Oh, no, it's right. I just did the wrong one.
What the heck?
Hold on, wait.
I did
You
not
sure
do
right?
that.
Do we need to go over
I
it?
didn't have my 1.
So where's our discrepancy at?
Oh, yeah, you
Mine was my own fault. I just did, instead of -3W, I
Yeah,
did
you use the ones you
-3Z.
use.
We already found them, so we just had to put them together, right? So I have to add 12 plus 12 is,
24.
and -4 plus -15 is,
-19.
-19.
Somebody got a hard time.
Any other discrepancies?
Shouldn't have rushed.
How do we feel?
Good.
Can we multiply?
Yes.
All right. So we're going to tie it all together. All right. So recapping what we've learned, we now have gone from just points on the coordinate to identifying their vectors. So these are our components. So this is your component A, and this is your component B. A tells me whether I'm going left or right, and B tells me if I'm going
Over down.
up or down. Okay. Then we talked about how to graph them. If we're graphing from the origin, we simply count up and down. Correct? We agree?
Yes.
All right. So now we're going to go back to magnitude. Can someone tell me what the magnitude formula is?
R sine of theta.
No. What's the
Hold on, wait.
magnitude formula?
Magnitude is positive B
Yeah.
plus B squared.
Yes.
Okay. The magnitude formula is the square root of a squared plus
B squared.
b squared.
And it's absolutely right. 'Cause
Okay.
fraction became
Yes.
negative.
Huh? Yes, it's very similar for when we were talking about polar coordinates as it being our formula for our radius. Yes. Okay, and so here it would become, what's my A component?
4 squared plus 3 squared.
And that gives me square root of 25, so my magnitude is,
5.
okay? We can't let things like that go away. Even though we talked about magnitude on Friday, we cannot say, oh, we're done with magnitude because we're still talking about vectors. All right, now we're going to go into direction. Direction was based on theta equals the tan inverse.
Of 3 over 4.
So for the
B over A.
my B over my A, correct? So in this case, what would B over A equal?
304.
Oh.
And so in decimal, what is that?
0.75.
Okay, because we are calculatorless temporarily, right? Because number 11 is going to reappear. What would I need to do to solve this problem? Use my what?
Use this.
Unit circle.
No.
My what?
Your T chart.
My trig chart.
I mean trig, not
See, something happened to it.
So I'm going to open up my trig chart, go to my trig chart. I'm going to go to tan, and I'm going to look for my reference angle. Look for,
0.75.
going to go down, go down, go down, go down.
37 degrees.
37
And then my answer is
37.
37 degrees. So my reference angle is 37 degrees.
So is that the direction? Yes.
It's going to help me find my direction. Remember, the table gives you your reference angle. Okay? The table is providing you with your reference angle, your
Because it's
direction.
in the first quadrant.
Exactly.
So it is.
But because we are in the first quadrant, like Nikki said, it is actually
It's your angle.
it's my angle.
So,
So theta equals,
It's in your first quadrant because your numbers are both positive.
ding, ding, ding. Both of my components are
We're gonna get along this 6 weeks.
are positive. And so I'm in the first quadrant. And my reference angle says, how far am I away from 0? What did it tell me? 37 degrees. So my theta, my direction is,
I'm gonna just write both of them.
right what?
My 75 degrees and the 37.
It's not 75, that's 0.75.
0.75. Same.
No, it's not. 75 degrees and 0.75 are
Nah, but you know
totally
what I
different.
meant. You know what I meant. You're trying to-
Don't say they're the
Right,
same.
you're trying to make me feel silly.
Don't say they're the same. All right, we're going to do 20, and I'm going to leave you to do 2 and 19 and 21. So on 20, what is my scale factor telling me I'm doing to my
You negative-
component?
Your top, you
Your
negative
times
top.
it, multiplying it by 2.
So it's going to become,
Negative 4.
86.
and
Oh,
negative
no, we're doing
3.
20.
Just kidding. That's what I got on there.
All right, so I'm going to plot it. Starting from origin, -4 to,
Negative 3.
there's my vector V. Okay, so looking at this, what quadrant am I in?
Third.
3.
So you.
So I know whatever reference angle I get, I'm going to be adding it to what? 180.
37.
So I'm going to be adding to 180. All right, so let's find my magnitude. Square root of
You're gonna get 5. 'Cause you
Negative. Oh.
can't
a
square
negative times a negative is a
Positive.
positive. So is there any reason to write a negative squared?
No.
No.
It's still 5.
Yes, Don, good job.
In your direction is 37 degrees.
Okay, my direction is not 37 degrees.
Cause you gotta go.
Oh, I mean the reference angle is 37 degrees.
All right,
The
so my
direction-
theta is tan inverse of 0.75, right? So I went to my chart,
Oh, it's the same.
and my reference angle is what?
175.
37 degrees.
0.75 was 37 degrees.
So my theta equals
217.
37 degrees.
What? I feel smart.
Oh.
Don, what are you saying back
I
there?
don't know. We're gonna write what you said, Nikki.
Are they all 0.75? They are. Well, this one's negative, but it's still 37 degrees.
A negative divided by a negative is a positive. So it's technically still
My
positive.
stomach just touched my back. I'm hungry.
So,
All right, so I'm gonna give you,
217 also.
Bell for the ring, you want me?
the bell rings at 50,
Oh, I thought it was 40.
doesn't it? I'm gonna give you 2 minutes to try to,
11:50.
huh? Yeah. It's only 42.
I'm thinking about lunch.
I know, it's 42. You have 7 minutes.
To do what? 21?
I'm gonna give you 3 minutes, so at 45, I'm stopping you so we can do the last part.
To do 21?
To do 19 and 21.
3 minutes.
3 minutes.
This is a weird magnitude for the last.
Yes, it's 7.5.
It is?
The magnitude for the last one?
Yeah,
7.5.
I hadn't gotten there.
Can someone tell me really quick what the scalar is for 19?
For 19, I got 8 and 6.
10 and 37.
8, 6. What's my magnitude?
10.
10.
And what's my direction? So even though my vector got longer, did it change the direction of it? No. Perfect. Moving on. All right, what do we get for 21?
-6 and -4.5.
And
-4.5.
And, magnitude is 7.5.
my magnitude is 7.5. And my direction is
7.5. Let me see. Hold on.
okay. So compared to number 20, oh, I didn't graph it. Sorry.
It's between 82 degrees and 83.
So compared to number 20, my direction didn't change. I just extended a little bit in size.
It's in the
Correct?
third quadrant. Let me see.
Yes. So I'm in the third quadrant, so I'm going to be added to 180.
180. So,
Any questions?
yes, ma'am. When we got 7.5, you know, because of that's the
7.5 is your magnitude. 0.75 is your
-4.5
inverse, your tan value.
-6. Hold on. I'm going on with
All right. So subtracting vectors is pretty much the same as adding vectors. Do y'all remember the whole leave, change thing? Okay, that's what you're doing. When you're subtracting vectors, you're going to leave the first vector alone. You're going to change your operation, and then you're going to change the signs of the second vector. Mathematically, we represent changing signs by multiplying by -1. Okay, so I'm going to leave z alone. So z is still going to be 6, -2. I'm going to change my operation, so it's going to become addition. And I'm going to change the signs of w. So instead of a -4, it's a, and then this is a -5. Now, it's just what? Vector addition. So what's the resultant?
10, -7.
Good? Did I lose anyone?
No, I'm sorry.
Yes, Don?
So,
You got it.
why did you put 12 -4?
Because it's subtraction.
Keep change.
So I leave the first one alone. I'm changing my operation, and I'm changing the signs of the preceding vector. So the vector was -4, 5. Because it's subtraction, it's going to become +4, -5. So let's do it again. So I have 2z here. Again, you do the scalar first. So I'm going to do 2z. So what actually happens to, what is 2z?
12 and -4.
Okay, so I have 12 and -4. So I'm going to leave that alone, change my operation, and change the signs of w. And I end up with +4 and a -5.
Which leaves you with 16 and -9.
There you go. Okay, let's do 24, and then you're left with 25 through 27. All right, 24, I'm going to leave z as is, and so z is 6, -2.
You got 14 -.
I'm going to first do the scalar of w, and then change its sign. So the scalar of w would be,
8.
8 and
-10.
okay, so it would have been a -8 and a +10, but because I'm subtracting, it's a +8 and a -10. Now I can find the resultant.
Wait.
I got 14 and -12.
So we multiply first,
Yes, just like PEMDAS.
and then we change the sign.
Yes.
So it would be -8, +10.
It would when I multiply, it would be -8, +10. And then I'm going to change the signs, and it becomes +8.
It would be +8 because -2 times.
No, no,
Okay, I see. Okay.
You do the scalar first.
It's got a pattern.
Well, I just forgot that was
Leave,
subtraction.
change. You saw it? You see it
I was
happening?
about to tell us.
It's leave, change. It's the pattern.
That's what I'm talking- See it right there.
Hmm?
No, you know. God dang.
All right.
You can't handle sarcasm.
Good. That is it.
The right side.